Today is April 28th, and I will be doing question 13 from lesson 5.5. In the textbook, it is found in page 247. So the textbook question says the height h in meters of a toy rocket at any time t in seconds during its flight can be estimated using the formula h equals negative 5t squared plus 23 plus 10, which I've written down. Write the formula in factored form and determine when the rocket will fall to the ground. So to write the factored form, I'll first look for a greatest common factor, and I can factor out this negative sign. So it would just be, take that out. And change the signs of the positive numbers. So that's supposed to be 5t squared. And that should read minus 10. So, now that our negative is factored out, we can use the greatest common factor. We can list out all the common factors of the first and third terms. So 1 and 5 for 5. 10, we have 1 and 10, 2 and 5. Maybe I should write this 5 in the same level. So by trial and error, we need to get the multiplied factors to equal negative 23. So we first try with the first pair. 1 and 50 will not work. 10 and 5 won't work. 2 and 25. That will work. But we need 25 to be negative. So I'll write that in permanent. Positive 2 and negative 25 make a negative 23. So our final answer will be in brackets. So remembering that we have the negative sign outside of the brackets, I put that in front bracket. The first term of the bracket will be the first factor, and I cross over, meaning 5 would be here, positive 5. Or actually negative 5. So this also becomes negative, so that 5 times negative 5 becomes negative 25. The other bracket reads 5t plus 2. And that is our final equation. But there's one more thing the question asks us to do. It is to determine when the rocket will fall to the ground. So when it falls to the ground, the height will be 0. So I will set the h in the equation to 0, and then solve the rest. So I've taken the two brackets out and solved for the x-intercepts. One is negative 0.4 and one is 5. Obviously, the distance the ball lands would be a positive number, so this one is correct. And so it's 5. So the time it would land is 5 seconds. So to recap, we cannot have a negative time that the rocket falls to the ground. Obviously it's a positive time. So final answer is 5 seconds.